The Mid-Mississippi Valley has a rich history of major weather events. Some documented even 100 years ago and still rank high amongst the nation's worst disasters. My name is Jennifer Rickavi,
Winds and some large hail.
veteran meteorologist for WPSD Local 6. I want to take you on a journey through the past century to explore the impact of past weather events and the evolution of forecasting and technology along the way. My career spans more than 20 years here, covering some of the region's worst storms and also learning from past weather events that have changed our landscape. Over the past year, our team traveled to several states and collected stories from exceptional researchers, scientists, and witnesses involved with these events, all in an effort to show how our region's struggle with Mother Nature has also led to resilience. Those struggles were not in vain.
Get everybody in the coolers.
The people here need a lot of help.
Back to it all, I hope you hear.
I remember sitting at one of the tables and hearing somebody on the phone saying Dawson Springs was hit and there's at least a dozen dead.
Morning of March 18th, 1925. The nation's deadliest and longest track tornado, the Tri-State Tornado, was about to take form on the horizon. Mount Vernon, Illinois native and Storm Prediction Center meteorologist John Hart was part of a team that reanalyzed the tornado and parent storm, but with modern insight.
It was a very interesting upper system that came out in 1925 that produced the Tri-State Tornado. It was very cold in the mid-levels. It was probably typical if you lived there. There would have been rain the night before, actually flooding rain. It laid down a boundary across southern Illinois that aided the thunderstorm when it formed back in Missouri, noon, 1 p.m., something like that. The storm initially started producing tornadoes south central Missouri in the hills and mountains. But once it started producing and it latched onto that boundary, it was able to continue through the afternoon and produce just prodigious damage and loss of life all the way into Indiana.
Other folks told me that they felt like that was like two storms merging.
Before that deadly day, people were aware that a tornado, or sometimes referred to as a cyclone, could happen in this region, but very few knew the site of one or the clues that one may happen. Murfreesboro, Illinois native and meteorologist in charge Steve Piltz also researched the storm and gives us an idea of what forecasting was like back then.
I think the official forecast for Murfreesboro that day was showers turning cooler with shifting gusty winds. It was very generic, it was done very centrally, and they weren't allowed to use the word tornado in a forecast like that. Probably most folks in this area would say that, if you could talk to them, would say that they saw a boiling black mass of cloud coming. They didn't really recognize it as a tornado. So there wasn't the visual clues.
Graphic eyewitness stories emerged in papers across the country when word reached of the deadly storm. One survivor, Michael Kiley, engineer of the Mobile and Ohio passenger train, recounted his view of the destruction.
We were pulling into Murfreesboro from the south at 2:35 p.m. when the tornado struck. Our first information that something was wrong came when the wind began to whistle through the cab and the engine was pelted with flying boards. Then we saw the terrific funnel-shaped cloud approaching from the west and saw houses crumbling before it. The air was full of wreckage.
The Great Tri-State Tornado carved a 217-mile path, sometimes a mile wide, from Missouri into Illinois, then on into Indiana, moving at times at a record 73 miles per hour. During the more than 3.5 hours duration of the Great Tri-State Tornado, some towns were merely wiped off the map.
My uncle was at Logan School in Murfreesboro and was a student there when the storm hit that day. And so he was telling me these stories way back then, how he was at recess and he was outside and all the black clouds to the east were racing in from the east to the west. And that was really unusual for them to notice that. But he noticed that even at a grade school age, and he was also very interested in weather too. The teachers got them all back inside, and just before the tornado hit, so they got down, they were in their hallways, and he remembered looking up and seeing pieces of the building flying through the hallway.
It was an overwhelming loss of life and property, unparalleled even today.
I think it may have been the turning the corner for the country of understanding just how bad a tornado could be, and that things needed to happen to try to mitigate that. So better communications, better science, all of that needed to happen, and I think it did with that storm, and that's kind of led us to where we are today.
The impact felt from severe storms continues, of course, but the significantly reduced loss of life has been accredited to discovery research and the use of radar to track storms.
To think back to not seeing anything with a tri-state tornado except the sky, essentially, to what we can see now every 2 to 3 minutes on these radar scans is truly remarkable.
In March 1948, Tinker Air Force Base in Oklahoma suffered back-to-back strikes.
Tinker Air Force Base, what's credited as being the first tornado forecast, was they had the Air Force Base hit by a tornado March 20th of 48. And then, they're upset. It does a lot of damage. And, it's like, surely we can do something about this. Well, lo and behold, the Colonel Miller, one of the pioneers in early tornado forecasting pattern recognition, they were looking at it with his crew. They said, wow, today, on March 25th, 5 days later, looks pretty similar. What do we do with that? And it's like, well, I guess we have to take this up the chain of command and say, we might get hit by a tornado today. And of all things, it happened again 5 days later at the exact same location. I've been working my entire career waiting to see a day that was that repeatable down on the local scale, and I haven't seen it.
One of the first modern and scientific storm chasers, the late Chuck Doswell, worked hard to establish the science behind supercell storms and the tornadoes they produce.
The research that we had done at National Severe Storms Laboratory had certainly underpinned the notion that tornadoes are more or less unique. And so in order to understand them, you have to study them individually. And then when you get enough of that behind you, perhaps you can generalize. But it's hard. They don't submit easily to analysis.
We have ignition.
The first weather satellites were launched from Cape Canaveral in 1960, and the advancement in technology and forecasting really began to take off. Within a decade, the U.S. Weather Bureau was transformed into the National Weather Service we know today. Then a second and third generation of radars was commissioned.
And we have this new severe thunderstorm warning until 2 a.m.
The 1980s were a time of communications growth as radio and TV became crucial to conveying those weather threats, and it came at a pivotal time in society. Billion-dollar disasters set course on a sharp incline in the decades ahead as the population grew and material wealth increased. Still much more to come on A Century of Storms. Next, looking back on a first-of-its-kind storm that hit our area and what scientists across the country learned from it. Plus, how radar, warning systems, and real-time coverage evolved to meet the challenge. Stay with us. Extreme weather became more normalized for our region as early as the 1980s, and many of the events we're about to look at either inspired new technology or the development of further understanding why they were happening. During the afternoon of July 2nd, 1980, destructive winds caused widespread damage to our 4 states, claimed 3 lives, injured dozens, and killed hundreds of livestock. That storm would be identified as a derecho, a long-lived straight-line wind event, and the first time a storm of its kind grabbed the attention of scientists. Research would follow, and Doppler radar would become instrumental in identifying wind threats in the future with advanced warning. 2 years later, an F4 tornado struck the heart of southern Illinois in the middle of the afternoon on May 29, 1982. It claimed 10 lives and left 1,000 homeless along Route 13. Doppler radar had not yet been fully implemented, so tracking technology was as simple as only being able to see areas of precipitation. To really see what was happening, it was essential to get verification of what was being seen as different looking on radar. This is when law enforcement became trained weather spotters, for getting the warning out with visual verification were critical to saving lives. That storm also led to an increase in outdoor warning sirens along that part of Illinois. The need became very clear that radar upgrades were needed to see different aspects of the storm. Chris Knowles, the meteorologist in charge for Paducah National Weather Service, notes the impact Next Red Doppler radar would soon have to be able to detect more than just rain, the ability to see wind velocity and wind patterns.
That's when we started to notice improvement in terms of performance, and we started to discover many things that we'd never seen before in terms of signatures and patterns and et cetera on the radar.
It's kind of like a radiologist looking at x-rays, trying to identify these really subtle things in a thunderstorm that are extremely important. And Doppler radar was the big advance in the 80s and 90s to show us circulations inside thunderstorms and where the tornado might form.
A new generation of radar brought upon a new decade of extreme weather with more than a dozen strong to violent tornadoes in the surrounding area. The strongest U.S. tornado of 2005 struck Earlington, Kentucky as an F4, carving a path of damage through the Moores, Big Bear, and LBL. The Missouri Boot Heel, northwest Tennessee, took a direct hit during the evening of April 2, 2006, after two EF3 tornadoes struck, killing 24. Continuous television and radio coverage of storms was normalized during this period, showing how real-time information sharing developed between the National Weather Service and broadcasters. While the early 2000s were coming to a close, two historic events were about to test the strength of our overall infrastructure. The remnants of Hurricane Ike in September of 2008 and the ice storm of January 2009. They prompted back-to-back state of emergencies and consecutively the largest power outages in Kentucky's state history. Our physical landscape changed, and so did the way we prepared for high-impact events in a life-saving way. Thanks to National Weather Service investment and upgrades to computer modeling and higher resolution data, it allowed us to better forecast and warn of the impacts the ice storm would have on a local scale. Later that spring, another derecho event swept across southern Illinois on May 8, 2009, sometimes referred to as the Inland Hurricane event. And since it was one of the most intense and unusual derechos ever observed, meteorologists refer to it now as a super derecho. When we come back, our region is no stranger to major flooding either, from the Great Flood of 1937 to record-breaking waters of 2011. Next on A Century of Storms, what we've learned along the way in order to stay ahead of flooding. As we turn the corner into spring of 2010, large-scale flooding begins to change our landscape in ways not seen since the Great Flood of 1937. The flood of 37 led to engineering flood walls and levee systems. For forecasters, focusing on protection comes along with finding the answers to how and when it may happen again. Hydrometeorologist Jonathan Gurley works for NOAA's National Severe Storms Laboratory, working to advance modeling and forecasting of flood and flash flooding events.
We have a lot of models that take the rainfall information, if it's observed rainfall or forecast rainfall, and then puts that through a modeling system so that we're predicting things like how much water would we expect in the rivers, what's the flow rate and things. And that's useful for a lot of the river forecast centers. But to get it to a level where you can really start to see impacts from it, and what I mean by that are, what specific highways are going to be underwater, what buildings are at risk and things of that nature, then that's where these newer technologies kind of take those forecasts to the next step. And a flood inundation mapping is one way to do that.
The Cumberland River flooding of 2010 from Nashville to Kentucky took center stage on TV as I-24 went underwater and residents lost homes and belongings downstream toward the Ohio River. 2011 tested the flood wall and the levee systems in place. And while the activation of one of those levees left behind years of farmland recovery, it did ease the potential loss of large communities in the midst of the flood. As we continue tonight, modern advances in technology give forecasters a new tool to track tornadoes like never before. But almost 100 years later, history repeats itself in the worst way. Hear from those who tracked the December 10th tornado as they saw the storm unfold in real time. Doppler radar was about to take a giant leap forward in detecting tornadoes and other high-impact weather events. The modern upgrade to dual polarization radar.
Now we're able to actually see not only where the tight circulation is formed, but where debris is being lifted off the ground and how high the debris is, and the plume of debris as the tornado continues, what direction it's drifting.
As the new radar upgrades were being installed, the frequency of violent tornadoes continued to climb. The proximity of the Mid-South region to abundant moisture from the Gulf and powerful storm systems exiting the Rockies makes severe weather possible any time of the year, any time of the day. Tornadoes that occur at night have proven more deadly and are common during the fall and winter months. It was during the pre-dawn hours of Leap Day that 8 people lost their lives when an EF4 struck Harrisburg, Illinois on February 29, 2012. Another EF4 tornado claimed a life after leveling several homes in Perryville, Missouri, long after sunset on February 28, 2017. It took every element from storm spotters to NOAA weather radios, television broadcasts, and real-time information sharing and advanced radar detection to save lives in those events. But what happens next will be the greatest test of all. The images are instantly recognizable and remind us that even after nearly 100 years, the unimaginable happens right here at home. December 10th, 2021. Eerily familiar to the Great Tri-State Tornado in terms of region, longevity, impact, and violent nature. Even as the storm was just beginning in Arkansas, meteorologists working the radar at the National Weather Service in Paducah were growing more concerned.
It was all by itself. It was in the right place, and it just had that certain look, and any meteorologist will probably tell you, if they looked at radar long enough, you know when you see the one.
It's increasing in intensity. It's moving toward a mature phase supercell is what we call it. Then once it stayed like that for about 30, 45 minutes, I'm like, if nothing changes to the east and the northeast, ahead of this track or to the southeast of this track, then we could be looking at something serious.
This seriousness would unfold over the next several hours, and all hands were on deck as word arrived from Casey, Kentucky.
We had a couple of amateur radio operators in here, and they heard information. I don't remember the source, but they were talking about damage at the firehouse, I believe, the fire station there, and possibly a fatality, or maybe they had already confirmed a fatality pretty quick. We knew based on that report that this thing had fired up back to the intensity that it was before the cycle. So, of course, that set off the alarm bells again. It's like this thing is doing as we expected, that it was going to mean a high prolific tornado-producing supercell.
The intensity of the event led to another milestone for the Paducah National Weather Service as they issued their first ever tornado emergency alert for Mayfield. Several would follow as the storm roared towards the lakes and the Pennyrile.
This is a life-threatening tornado.
The communication of this was critical in saving lives that night, from social media to television broadcasts.
I remember sitting at one of the tables and hearing somebody on the phone saying, Dawson Springs was hit, and there's at least a dozen dead. It's where my family's from. Yeah. It's a very difficult, emotional moment. And of course, cell phone service went out. And so it would be more than 14 hours until I knew whether my close relatives were still alive.
Bashir reflected on his being in Mayfield at first light, standing next to Mayor Onan and Chief Kent outside the candle factory.
One of the most violent scenes that I could have ever imagined. At the time, we thought that there were still 100+ people inside, because that was the information we had, and the chances that any of them were alive.
Christine Wilgus is the warning coordinating meteorologist for National Weather Service Paducah and remembers her drive to survey the storm damage the next day.
And I remember we crossed it over that hill and I just gasped. And I said, oh my gosh, look at this. It looks like a bomb went off. And so that sinking feeling in your stomach, like this is unlike anything I've ever seen before. And I've been through Evansville, I've been through Madisonville, a lot of the bigger tornadoes, and this, didn't even compare.
Next on A Century of Storms, the death toll from tornadoes has dropped dramatically over the last century, but the work to protect every life isn't over. How meteorologists are using past disasters to predict future storms. And what could the future look like for forecasting? A Century of Storms returns right after this. Both the Tri-State and the December 10th tornadoes were long-tracked and stayed on the ground for several hours, changing lives and landscape along the way. 89 people died during the tornado outbreak of December 10th, the highest ever recorded during a December event. The tornado death rate continues on a sharp decline since 1925, but the work to protect every life continues.
I hate to think that we've had practice, but we have. And our people have seen how destructive this can be. And so in all the natural disasters that have happened since, and we've had a number, what we have seen is more people aware of it ahead of time, a much lower loss of life or even of property. You see us getting better at preparing and responding.
The way we communicate preparedness and alerts also continues to evolve. As the future of tracking and forecasting storms,
you can't even comprehensively try to explain everything that we've done, from weather radios to social media to the internet. Things like YouTube, and you got broadcast TV.
The radar imagery and data from the December 2021 tornado are already being put to use in helping fuel the next generation of storm warnings.
So we actually perform what we call retrospective runs. When we don't catch a case in real time, we'll go back and study it. We actually have a second experimental version of the Warrant Forecast System that runs at higher resolution, down to 1 kilometer. And that performed really well in capturing that storm, being able to predict it and that track a couple of hours ahead of time. So that kind of information is what makes me really excited that 5-10 years from now, forecasters will be able to use that to say, okay, we've got a storm that's already starting to produce tornadoes. Let's warn folks an hour, 2 hours downstream that their probability of a strong tornado is really going up.
Each thunderstorm and every tornado is different. Meteorologists pursue the answers to why one thunderstorm produces a tornado, yet almost an identical storm doesn't.
Serendipity happens. But I don't think the secret of tornadoes is going to fall that easily to serendipity. I think it's going to take a while. You got the basic notion that converging airflow tends to make vortices spin up, and we know that has to be at work in tornadoes. But why some do that and others don't, even in the same area, same general location, but one storm produces a massive tornado and the other doesn't. What's going on? We still don't know. I'd be disappointed if it turned out to be something easy.
Enduring all of these horrible disasters is what it takes to reveal weaknesses and facilitate change. There will likely always be the element of the unknown, the inability to forecast with 100% accuracy. Striving for best practices in preparedness and adapting to become more resilient. That's how we build stronger households and communities for the next century of storms.